today we're going to do binomial distributions. So a binomial experiment has two outcomes. You have a success or a failure. You're going to pass or fail. It's going to rain or it's not going to rain. You're going to make the basket or you're not going to make the basket. You're going to catch the ball or you're going to not catch the ball. There's no in between there. Okay? So the probability of success has to be the same for every trial. They're going to call that the P value, the probability of success. It remains constant. So these are independent events. The probability of the first happening does not affect the next trial. The probability of failure is just going to be the complement, 1 minus P. And in the formulas, you're going to see that as a Q. And X is the number of successes in N number of trials. Okay. So we need to know the N stands for how many trials we're going to have. The P stands for our success rate. The Q stands for the failure rate, which are complementary. And X is the number of successes. So those four variables, you need to know what they mean. All right. So, determine if they are binomial. A certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So is this a binomial situation? Yeah, the surgery is a success or it's not. There's no in between. So what is the N? How many trials are we? 8. There's 8 patients, okay? What is the P? What is the probability of success? 0.85, right? And what would the failure rate be then? 0.15, very good. And X is the number of surgeries. Successful ones. Okay? All right. So X could be 0 all the way up to 8. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacing. The random variable represents the number of red marbles. So it's not, you don't only have 2, right? It's not either blue or red or whatever. So there's 3 possible outcomes, and we are not replacing, so it's not independent. It's dependent. Okay? So that's a big old. All right. You have to be able to explain why, though. Understand. Okay? All right. The binomial probability formula. So this looks complicated, but it's really not. You have this combination, the NCX, because instead of the R, we're going to use an X. This part is the same as this. That's just the factorial formula for NCR. Okay? Times the probability of success raised to how many successes you have. Times the probability of failure raised to how many failures you had. That's all you have to do. Really not a hard, bless you. Not a hard formula at all. It looks more complicated than it is, truly. Okay? So N stands for how many trials. X stands for how many successes you want. The P is your success rate. Your Q is your failure rate. P's and Q's should always add up to 1, right? They're complements. All right, so let's look how this works out. So we have rotator cuff surgery has a 90% chance of success. So I'm just going to start writing what I know. So I know my P is 0.90. The surgery is performed on 3 patients. So the N equals 3. What does the Q equal? If my success is 90%, my failure is? Okay. Find the probability of success on exactly 2 patients. So my X is 2. So again, here's my formula. NCX, e to the X, Q to the N minus X. And guys, that looks complicated, but it's just, if I have 2 patients that it was successful on, I have how many that it wasn't? 1. You're just the rest of the people, okay? So you're going to do 3 C2 times 0.9 to the 2, these are the same, times well, I have to put 10, but you don't have to the 1. You just got to type that in your calculator. That's it. So it's total number of trials, C, how many successes, times, you don't even need the time symbol, I don't believe, 0.9 to the 2 times 0.1 to the 1. And you really don't need the parentheses. I'm just putting them there so they're separating things. I get 0.243. So what you got? We can write that as 24.3% chance of it working for exactly 2. Okay. Easy enough? Good? All right. Still recording. There we are. All right. So in a survey, U.S. adults were asked to identify which social media platforms they use. The results are shown. 6 adults who participated in the survey are randomly selected and asked whether they use social media platform Facebook. So the question is, do you use Facebook or do you not use Facebook? Construct a binomial probability distribution for the number of adults who respond yes. So you only have 2 possibilities, right? Yes or no. Okay. So, this is your distribution. I'm going to write it vertical because I already had it up there. You know what? I don't want to do that yet. We're going to hide that from you. Here we go. So, sorry. We've got 6 adults. So what's the probability of none of them wanting Facebook? So 6C0 times, what's the percent like Facebook? Can you guys see it from there? It's 68%. So my success rate, because I'm considering that a success, that's a yes to my question, to the 0 times, what's the failure? What percent do not want Facebook? 32? And then what would the power be there? 6. So you put that in your calculator and you get an answer. And then the other possibility was it could be 1. And you just have to do this for all of them. You're creating the binomial distribution. So I could have 1 person likes Facebook and 5 of them don't. Or I could have 2 of them like Facebook and 4 of them don't. Does that make sense? So you put it in this table. That's where we're getting that. The probabilities of this probability distribution should equal 1. We talked about that yesterday. They're all going to be positive, obviously, because they're probabilities. All right? But that's your probability distribution. It's a pretty high percentage of people liking Facebook. So you should have higher percentages later with more people than you would earlier. Okay? Everyone understand how to do the probability distribution? And you just do that until you're doing 6C6. Everybody good? Okay. Now let's use our calculators. Even though this really, to me, it's almost harder to get your calculator out and put this in than to just do it. But you are randomly, you survey 26% of the U.S. adults believe there's no difference between secured and unsecured wireless networks. You randomly select 100 adults. What's the probability that exactly 35 believe there is no difference? Okay? So what is my N? How many people are in my 100? C, what is the X? 35. What is my success? 26 to the 35th. What percent believe there is a difference? 74. And how many believe? 65. That's your formula. This is not complicated to do. So get your answer without using what I'm going to show you. Just put it in your calculator like that. It's about 1%, right? Okay, so if you have your graphing calculator, you want to get it out. Okay, we ready? You're going to go to second distribution. Distribution is right here, the bars button. I arrow up because it's quicker. But we want to go to binomial probability distribution. Bree, I'm going to take your watch from you. Binomial probability distribution, so you want that guy, which is A. Number of trials is 100. Probability of success is 0.26. X value, what do we want it to be? 35. So seriously, it takes almost as much time to get to that and type that in as it is to type in the formula. Now, when this is helpful, okay, what if they said, at most, the word at most, 35 adults. What does that mean? It could be 0 adults, or 1, or 2, or 3, in which case you would have to do the trials all the way up to 35 and then add all those results together. So if you had to do something like that, I could see using the probability, because you can also do this. A survey found that 70% of U.S. adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether Google News is a major source of news to them. What's the probability that exactly 2 answer yes? Go. Mean is number of trials times the success rate. Variance is N times P times Q. And then the standard deviation is still the square root of the variance. Okay. So very easy. 1 out of 5 students at a local college say they skip breakfast, so that's the P. Find the mean, standard deviation, and variance of 10 students are randomly selected. So our N is 10. What's our Q? 4/5. So our mean is just N times P. How many do you expect to answer yes? 1/5 times 10 is 2. So our variance is 1/5 times 10 times 4/5. So that's going to be 8 over 5, or 1 point something or other, 1.6. And then our standard deviation is the square root of 1.6. Which is 1.26. So mean, standard deviation, and variance are very easy to find with binomials. Okay? We good? What time's the bell ring on connection day? 23. We are done.